My name is Joseph Fontes. I am a solutions architect with Amazon Web Services. And what that means is that I work with customers and partners in order to facilitate the technical adoption of the framework. Today we're going to be going through global encrypted deployments of NGINX on AWS. Due to the design of AWS, there's a lot of different ways that you can, facilitate deployments. Kind of one of the things we always say, it's not for the things you can think of, it's for the things that you can't. And so during the demonstration today, we're just going to go through a couple of possibilities of different things that you can do on the platform. Probably throughout the conference thus far and throughout the conference moving forward, you're going to be presented with a number of other options for deployments on AWS. So this certainly isn't the gold standard. This is just one way that we can leverage the platform. For those of you not familiar with AWS, back in 2006, Amazon released S3 as a storage solution, the simple storage service. And what it allowed for was the modular, the object storage onto a provider that with seemingly unlimited storage capabilities at a cost-effective price to be able to store your files so that the durability requirements of your organization could be there without having to scale out your data centers. Moving forward, we now have over 70 services with AWS. Since then we've added compute, storage, networking, and then more advanced services, which we're going to go through today. And really, those are customer driven. When we say that we're a customer-driven organization, it means that when we do a product release or when we do a service release or new service, these are driven by the requests of customers. The services that we're going to be talking about today, the certificate management service, EC2, load balancing, VPC networking, these were all requested by customers. We received feedback that this is what customers and partners would like to see on the platform. These are the things that they would like to utilize, and thus AWS responded by building out these services. You'll notice that there are once again a lot of different ways that you could implement these services, and I'll try to go through some of the other options as we move forward. This is kind of core to the demo, to the presentation today, are the physical locations of AWS endpoints as well as AWS regions. This is a global network. So in the blue dots, you're going to notice these are AWS endpoints, and we'll go through exactly what the differentiator is. And right now, the orange circles are AWS regions. When you open up your AWS console, you're presented with the option to deploy your resources in an AWS region, and those are highlighted in orange. So as far as what is available today versus what is coming soon, we have 13 current regions with a few more on the way, and you can see them on the map here. We are constantly driving to deploy more and more resources for customers and partners. Each day, AWS deploys the amount of equipment that we utilized when we were a $7 billion business. So we're really trying to scale out, and that means new locations, new regions, new endpoints and availability zones. The availability zones, which are basically the way you think about them, are unique data centers within a region. There's a different number per region. If you notice, in Northern Virginia, we have 5 availability zones. The availability zones are, we don't say where they're located. I can't just walk over to Oregon and tour a data center. These are nondescript buildings, but each one is measured in a distance of miles apart from each other, and the idea there is that to protect against fault and failures and things like that. And then here are the edge locations, and this is what we're really going to be focusing on today, because this really gives us the leverage of the services we're going to be utilizing. The edge locations provide services that are closer to the end users. So today we're going to be talking about CloudFront, which is a CDN available through AWS, as well as Route 53, which is our DNS service. And these services are offered at the endpoint locations that you see here. And then, different customers, different industries will focus on different areas. Just to give you an idea to kind of run through quick, here are the endpoints and regions available in North America, South America, Europe/Middle East and Africa, and then Asia Pacific. And this gives you a good idea of how close it is that you can get your services to your end users today. AWS is constantly expanding, so this map will probably be outdated next year, but as of right now, this is the way it looks. And then I wanted to give a little bit of background on two of the services that we're going to be talking about, specifically EC2. This is your compute instance that you're utilizing. When you deploy a web server on AWS, you're deploying to EC2. When you deploy an NGINX load balancer, an NGINX web server, or an NGINX plus caching server on AWS, it's being installed on an EC2 instance. And so there are different types of EC2 instances. The instance type is decided based on the needs of the customer partners, so they're sized differently, and the pricing is associated with resources being used. But this is the one of the three core components of AWS. This is the compute side of compute, network, and storage. And then RDS, once again, as a customer request, in order to deploy databases on the platform, you can certainly, install an operating system on EC2. You can put MariaDB on there if that's your choice. But the feedback from customers was, I want to be able to run a database server in AWS, but I don't want to have to manage that specific service. And then, I don't want to have to manage high availability within that service, something like having a multi-master replication instance. And I definitely don't want to manage having read-only replicas, those slave instances all around the globe, because that's a lot of work. And so based upon that feedback, we worked for service releases so that we have RDS, which is managed database service, relational database service. And, MariaDB is supported, MySQL is supported, Oracle, Microsoft SQL Server, in order to PostgreSQL, in order to, meet the needs of customers based upon that feedback. And going with this idea of a global delivery of application services and load balancing, you can have your master server in a region, multi-masters across availability zones within a region, and then replicate that data globally. So this can be replicated to the additional regions available within AWS. And kind of the narrative we're going to look at today is the data is going to be available in multiple regions. Your load balancers are going to be available in multiple regions, but the end node, that content delivery, the very edge location that the customers are connecting to, those are available within all of the endpoint locations. And if you looked at the previous map, there are many more endpoint locations than there are regions. So when we look at scaling on AWS, and this is a really important activity within the infrastructure offering, you have different methods to scaling. There's vertical scaling, which is, I have a box that's running, a web server, or it's running an application server, and it's hitting more traffic, so I want to make it even bigger. You go from one instance type to a larger instance type to give you the ability to serve more traffic and do more. And we have many different instance types to facilitate those needs. This is an R3, for example, gives you additional RAM. The C series gives you additional compute capacity. And then there's the idea of horizontal scaling, which is, you take one instance and you turn it into multiple instances, or you take multiple and add more instances to it. And the idea here is that, you're not locked into, keep maintaining specific instances. It's kind of like treating instances as cattle as opposed to pets. You don't care if, one instance goes down, because you're just redeploying onto multiple instances. And then, the idea here is that, we definitely follow our own practices. When we looked at how it was that Amazon.com was run, back before auto scaling, in order to meet the needs of peak season traffic, those servers had to be provisioned year-round. So, in the middle of summer, if we're seeing a drop in traffic, we still have the same number of instances that we had, last December for peak season, or, the same number that we needed for Black Friday or Cyber, whatever the other one is. And so, that's a whole lot of wasted capacity. So, the idea with auto scaling is, to provide customers with the ability to scale when needed and to reduce resources when not needed. So some of the traditional patterns that you see with trying to figure out what resources are needed is that kind of same idea. You add physical hardware as you can to meet the needs. If you luckily have enough physical hardware, then you can meet the demands of the end users. If you don't, then that means that you're going to get the old slash dot effect and kind of run short on resources. And we have these, highlighted in green, we have these areas of waste, and these areas where, we're going to be serving more traffic than we have computational capacity to serve. And neither of these are ideal. It's, being able to serve the traffic that we need. And so with auto scaling, we're able to add resources and remove resources on the fly, so that we only have that which is necessary in order to operate. What happens with an auto-scaling instance is EC2 is running. It reports this information to CloudWatch, how many connections I have, what's the latency looking like, what's the CPU level at, and then scaling instructions are sent via SNS, so that we constantly get updates, so that if you say at 50% CPU capacity across the fleet, I want to add 10 instances at once or 10 virtual machines at once, those will be added. And this is kind of really important when we get into how it is that this is utilized within NGINX. So we have this queue of metrics, and it's applied to EC2 instances, and it's applied to auto-scaling groups. And what you have with these NGINX deployments is you have the NGINX offering, whether it's NGINX Plus or the open source version. You have it creating metrics, more metrics with NGINX Plus than with open source, but you still have these metrics being created. When you feed these metrics into something like AWS CloudWatch, you can make decisions based upon those metrics. And you can choose to scale out the backend servers. You could say, my NGINX instance is getting near peak, network throughput capacity, scale that into multiple instances. It's taking too long to respond, scale that into multiple instances. Or I previously had scaled it into multiple instances. Now traffic died down. There's no longer a marketing session going on. Let's scale that back down so that we can, reduce the cost of the spending. And so, there we go. And so with this new idea of auto scaling, you want to be proactive. So the scaling decisions, when you utilize something like EC2, are really up to you. You don't want to wait until the last second, because it does take time for these instances to boot up. But you might want to say that, when an instance gets to 30% utilization or 50% utilization, let's start spinning up the additional instances, so you have that buffer between 50 and 100%. So a lot of these things are what are up to the end users, up to the partners. Once again, we we got a little bit of feedback that said we don't want to have to manage things like this. So we do have additional services through AWS that manage a lot of these responsibilities, things like Elastic Beanstalk. And you can use NGINX within an instance in order to to run within a managed service. So a lot of those decisions are made for you. But for the most part, we see a lot of traditional auto-scaling deployments. And then, this is really specific to, my anecdotal experience. This does get really specific with NGINX. We have something called auto-scaling Lifecycles and then auto-scaling lifecycle hooks. If you're running an NGINX instance, and let's say that, as a placeholder, you have a really small instance, by default, you only see, maybe 50,000 hits a day, or, you're only getting a little bit of throughput, but you're getting ready for that big December marketing push. You've got a marketing email that's going to come out, and that you're going to see a lot of traffic coming through. You can be proactive and say, the day before, let's go ahead and schedule the deployment of a bunch more instances so that we don't have to wait for things to scale up. And that's really kind of being proactive to really, to say on December 10th, even though the marketing deployment is on December 11th, let's really, scale out based upon this event that's going to occur. And then, during this scale up or scale down, what changes do we need to make within the instance? If it's an NGINX instance, do we need to update the configuration in order to add the current backend? Do we need to, is the current configuration built in so that when it starts up, it's behaving properly within the cluster? Does it need to do notification intervals as far as, do I check in with Keep Alive D or Heartbeat, or, how is my addition to the network handled? And so there's a lot of different hooks available. This is, one example using a lifecycle hook. You can add, additional scripts or instructions to the actual image itself. You can handle lifecycle events in Lambda. It's once again, we give as many capabilities as we can think of, because it's not the solution that you can think of, it's the solution that you can't, which is always going to be what people prefer. And so, one of our recent service announcements, once again, we received a lot of feedback that people want to be able to utilize SSL encryption in more of a cost-effective fashion than has been traditionally available. AWS, we have a saying that security is job zero within our organization. And, we really mean that. It's, we want to see all web traffic encrypted. That is our end goal, and we believe that should be, everybody's end goal. So there have been a few different announcements made, things like Let's Encrypt that help to, deploy SSL certificates, to be able to manage SSL certificates. And so with AWS Certificate Manager, it's an additional way to be able to manage and deploy SSL certificates and encrypt HTTP traffic. We want to see all traffic encrypted. And so we provide this as a free service. It's in order to get this running, I think it's something like 5 clicks. All you have to do is own the domain and be able to receive emails on a few different options like postmaster at, or webmaster at, or admin at, and there's 2 others, I forget what they were. But as long as you can receive email on that domain, then you can verify that you are the owner of that domain. And so you click a little link that says, yes, I should have an SSL certificate for this domain. You can add up to, I believe, 10 aliases for this domain. And so it's trying to make things as easy as possible to add encryption to your web service. Right now, as it stands, AWS Certificate Manager works with AWS CloudFront, which is our CDN solution, and that's one of the examples we're going to be highlighting today. It also works with Elastic Load Balancing. It works with Elastic Beanstalk. And so there are definitely other ways in order to integrate it into your solution. But what we're looking at specifically today is a global deployment of AWS Certificate Manager, encrypting a global deployment of NGINX servers with multiple NGINX servers on the back end, handling back end traffic traffic and being globally routed by DNS. It wasn't just about making it free, it was also about making it easier. For those of you that have had to run through the process of getting an SSL certificate, you're creating your private key, you're creating your certificate request, you're processing that request through an SSL provider, you're receiving that certificate, then you're managing that certificate. How long until it expires? It's probably, about a year or so. You're migrating those certificates prior to expiration. You're managing services to warn you, is my certificate going to expire? And so this kind of makes it a lot easier to manage those things, as all that is managed for you in the background. Here are some basic features of ACM. Some of the things we talked about: the application to Elastic Beanstalk, being able to control where you deploy the certificates to via the console. I usually use the SDK for everything, so I automate a lot of my deployments with either Python or PHP or Ruby, and so all that can be managed from the SDK, and so deployed programmatically. And then, once again, the benefits, basically the benefits are free encryption of all web traffic. And that's really the end goal. And, this is one way in order to accomplish that. And then, I guess the key takeaway here is the encryption type, RSA 2048, SHA-256 hashing. And as it currently stands right now, these are applied to CloudFront, ELB, as well as Elastic Beanstalk. And so we're going to get into how do we use this with an EC2 instance with NGINX. Here's the current availability with ACM, and these are the different regional availabilities. Some of them are in the future. Some of them are currently available. This was a customer, as is always the case, we get a lot of customer requests for this type of service. A lot of customers and partners want to be able to utilize it, and so we're increasing adoption as much as we can right now. So what does the basic architecture look like when you utilize AWS with ACM, when you utilize CloudFront as the CDN? We're going to kind of dissect things a little bit, but from the 50,000-foot view, here we have NGINX running on an EC2 instance. We have CloudFront at the very edge location, and then the edge locations are actually broken up. Once you get to CloudFront, it's broken up into something called distributions, such that you can point different traffic to different locations. So that's the reason that we have like S3 here and we have non-AWS origin, is if you have example.com and you point it to CloudFront, if you want to point /images to Amazon S3, you can definitely do that. If you want to point, /app or /CMS over to NGINX and then have it branch into multiple other instances, you can definitely do that as well. And so that's highlighted in this example here. Here we have a lot of different endpoints. Once again, this kind of comes down to, your own personal preference. How is it that I want to deploy this? In this example, we're looking at a lot of different endpoints. So once Route 53, which is DNS, says, example.com points to CloudFront. So you always resolve example.com to your closest CloudFront endpoint. And so if you're in North America, you'll get something in North America. And once you get to CloudFront, where you go is based upon the request. So here we have some examples where, a subdomain with ads and a subdomain with clicks go to separate NGINX load balancers. We see that there's static web hosting with S3. That's the icon for S3. And then additionally, NGINX is the endpoint for European traffic, probably based within the EU. So that's a whole lot of endpoints, and you're going to drive your developers nuts. So there's definitely other ways that can be where this can be done. So if we take the example of, we have example.com and we point it to a single CloudFront distribution, and due to ACM, that is an encrypted connection, we can actually divide things up further on down the line. So, so here we have the example of, we have a single endpoint. We use Route 53 to do the DNS resolution over to CloudFront. And then we can actually do backend latency-based routing. So once you get to CloudFront and you say, I want, my backend app server is, apps.example.com, and that resolves to a bunch of NGINX servers all in different regions, it can resolve based upon latency. So maybe geographically you're closer to Frankfurt, but maybe Ireland is responding faster. You could be routed to Ireland. The other way it works is that you could say, it's your choice. If I'm in Germany, I want to stay in Germany. You can say that, you could break this down however you want. If it's something about EU data protection standards, you can say, route me based upon latency, but only within the EU. And it's obviously available in the United States. All of these are decisions that you make. It's you can combine latency-based routing with geographic-based routing to get to the configuration that you're looking for. So what some of the technologies that we're using, you can use CloudFront as an option. You can have Route 53 handle all load balancing for you. You don't have to use AWS CloudFront. This is just one example. It's really trying to offer as many solution options as possible so that you can configure it to meet your needs. And so, as we're talking about the different routing options when we have DNS, here's the example of that. So let's say that, once again, you're based out of Europe. Geographically, you are isolated to the European continent. So you get, right now, Frankfurt, Ireland, and I think coming soon is UK. From there, you can do latency-based routing to say, probably if I'm in Germany, I'm going to end up at Frankfurt. But if that region has not yet scaled up to meet the load requirements and latency is taking too long, I'll fail over, or I'll spill over to one of the other regions in that area. And then, this is once again kind of breaking up the endpoints a little bit so that, you can route your traffic as necessary. You can have multiple endpoints saying all static traffic can go to S3. S3 is a great solution for static traffic because it's really cost effective to store your images there, to store any static content there. And then you can make dynamic applications available through, NGINX as your load balancer. You can do, directly to EC2 instances. You can use an alternate load balancer with NGINX as your web server and caching server. I mean, you can use NGINX plus with their caching server so that you bypass having to use multiple instances on the back end. You can use, NGINX caching to replace out S3. It's really kind of up to you at this point. And then once again, this is the idea that you have multiple endpoints and you can combine them into one endpoint such that everything is driven through CloudFront. With CloudFront, you have the ability to create a lot of different distributions with a lot of different options each. If you have static content and you don't need things like URL parameters, like $ID is equal to 10, you actually don't have to forward those on. That's off by default. But if it's an app server, you obviously have to pass URL parameters through. And then once again, you can have that single endpoint pointing to Route 53 and then divide up the traffic based upon Route 53 DNS entries. So this is another way of load balancing as well. You can globally load balance with DNS, and then you can regionally load balance with NGINX or NGINX Plus as your solution, and then go down to the instance, which should be run across multiple availability zones in a region, running NGINX as your web server. And so the call to action right now is we have a new quick start that is available for NGINX. It was actually just released. This quick start allows you to view some of the new capabilities available with NGINX Plus. Since it is a quick start, it's going to be a very simple deployment. You just basically in the background, it's a CloudFormation template that runs and sets up a lot of the parameters that are necessary for deployment. And it is able to kind of get you going quick so that you can start utilizing the service and start looking at what are the capabilities of NGINX Plus versus, trying to get everything deployed exactly as you want. The URL on the bottom gives details about the quick start, and here's the example that's actually here's the example of what would be deployed. Multiple availability zones, which is the AWS recommendation, along with different a private subnet and a public subnet to isolate traffic. If you have your database running on a back end, you probably don't want it talking on a public IP address, that type of thing. And then, creating multiple instances to be able to, manage that load and traffic independently. Also, apparently dropped off this slide, but if any, there's 3 AWS staff here today, and we'll be here tomorrow as well. It's myself, Doug, and Carmen. We have AWS credits if you guys are interested in running some workloads on AWS, checking it out, trying it out, and so we can provide those as well. If you just kind of tell us some of your use case. We always like to hear, fun new ideas. And this doesn't have to be professional. This doesn't have to be for work. Some of the most fun examples that we hear are, people working on, home projects or doing fun stuff at home. We have AWS IoT offering. We have a lot of different services to try out. And then I wanted to open it up to questions. Yes, sir.
Regarding the certificate service, so what's the root authority? Can we use it in browsers? And the second question is, can we get the certificates out, which might be important if we use certificate pinning?
Right. So, all right. So the question, in case anybody didn't hear, one is what is the root CA, and is it so? Can you use the certificates in standard web browsers? Is one, and then 2, can you export the certificates out? So first answer, I believe the CA is VeriSign, but you're being generated a certificate off of an intermediate CA, which is Amazon. But I mean, yeah, all current browsers would support that. So I've tested as far back as like Firefox. I don't remember the number. So, but yeah, I believe it is. Second question is, can you take the certificates out? As of current release, you cannot. You can apply the certificates to the AWS services such as CloudFront, Elastic Beanstalk, and Elastic Load Balancer. I don't. Let's see. Right now, the management of these certificates is automated, and so right now, as it currently stands, they reside with the service for the automation. Yes. I'm sorry, I couldn't quite hear.
The locations of Amazon CloudFront, is that the same as the 56 edge locations you talked about, or are there even more locations?
Oh, so, okay, yeah, so the question was, that we listed 56 edge locations. Is that specifically CloudFront? Are there more CloudFront locations? Does it apply to all those locations? And as it currently stands, those 56 are for CloudFront and Route 53, which is our DNS service. We are always deploying additional capabilities within the infrastructure. So, those are the current endpoints, but, we're always growing. Yeah. And then any other questions about anything else AWS? NGINX? Yes.
So I have a question regarding SSL certificates.
Okay.
certs on the CDN and on the load balancer, and we had to create new, because we had to support two DNS names for going to the same website.
Mm-hmm.
And currently Underground does not provide a service to support multiple certs on the same CDN. We had to create another CDN and another load balancer. Do you have plans to do that in the future? Is there a way we can achieve that in your project?
Yeah. So I'm not sure when you got that response, or if that's ACM specifically related. But as far as it currently stands with capability, I'm sorry. The question was applying multiple SSL certificates to a load balancer or CloudFront, which may have different DNS names, and having to get different SSL certificates based upon those DNS names. So as it currently stands with ACM, and I think I forgot this, so that's my fault. You can have multiple entries on that list. You can use wildcard certificates. You can have aliases on there. So you can, let's say that you've got 5 different iterations in a wildcard that you want to apply to a single certificate. You can create that single certificate based upon that, and then you can apply that single certificate to CloudFront and have everything on a single distribution. But there's a catch, right? So the catch is that the end users by default have to support SNI, which allows them to kind of share that IP with SSL traffic. Or alternatively, there's an additional fee to get dedicated IP addressing, so that SNI would not be a requirement. Modern browsers, all that I know support SNI, so I don't think there's any issues. But I don't know how far back you'd have to go to see an issue. But yeah, so between wildcards and aliases, the catch is though that if let's say you have like different domain names under that alias, you have to validate each one. So like, let's say you do images.domain.com as one of them, you're going to get an email at postmaster@images.domain.com. So, you may have to kind of run and set up MX records for that so you can, validate it.
I was just going to say it was Windows XP SP2.
Okay.
They did not have SNI.
All right. As Service Pack 2, wow. We still run those in healthcare centers, so that's good to know. Thank you. All right. Well, if there's any other questions, we're at a booth. We've got stickers and things to wipe screens and AWS credits. And if you could just sit there and talk to us for a few minutes, we'll try to make it entertaining. Thank you.